Hi, hello everyone. Good evening. This is your Ameer sir, Master Teacher of Physics at Vedantu. Now, everyone tell me how are you all doing after a holiday? Because yesterday it was Republic Day, and I forgot to give you a belated Happy Republic Day wishes, right? So tell me, how was the holiday? Was it amazing? So I think you studied a lot. Along with that, I think you had some good time with your friends and family, some happy moments. Okay, I know that you all totally loved it and you all had an amazing day. I'm so much happy for that. And why we are here? Because here we are with another session of Rapid Sprint 2.0, which says it's study time. And here we are with another amazing chapter, alternating current, right? You all know what we have in this alternating current chapter, right? Because till now, before this chapter of AC, we were mainly dealing with the direct current, right? Which means a current which has a direction, right? Only in a particular direction, right? So here, alternating current talks about a current which constantly changes its direction and magnitude along with it, right? So we are going to discuss about the alternating current, right? The properties and the phenomenon it causes and the behavior of different elements, right? Different electronic elements such as capacitors, inductors, and resistors to this alternating current is what the important points that we are going to discuss in this particular session. Fine. And whenever I say discussion, we are going to do lot much of questions, right? Along with the questions, we are going to cover most of the theory along with it. Now, I hope you all are ready for that, right? Give me 1 minute. Let me put the live chat box on. Yes. So we have Siddhant in the class. Hi, Siddhant. And as you all know, before this alternating current, you can see what all topics we already have covered in this rapid sprint 2.0, right? So electric field, potential, capacitors, current, electricity, magnetic effect, magnetism, and EMI. All these chapters are done, right? So if you have missed any of these chapters, okay, after this class, type each and every chapter, okay, you will be getting the videos. We have done amazing questions, so don't miss it. After the class, you have to go and check it out, okay, and learn from there, because you all are going to grab a lot much of benefits for the upcoming JEE exam from all these sessions which you have missed. Now, before we proceed, one thing that I want to tell you, I know that we have some new students in the classroom. What do you all have to do? Okay, move your cursor now itself and click on that red subscribe button, because you don't want to miss any of the amazing videos which is coming from this particular channel, because we are mainly orienting in such a way that you all are going to get amazing ranks and marks in the JEE. So I think you don't want to miss that, right? Your ranks and your marks. So don't miss it. Move your cursor and get it subscribed now itself. And one more thing that I want to tell about the Telegram group of Momentum with Vedantu is, right. So in this Telegram group, okay, so we are uploading all the questions, whatever we are doing in this particular channel, right? So whatever questions you are missing, or if you want to have a preview of all these questions, whatever we are discussing here, you can actually join in the Telegram link and have a look at it, right? So before you actually come for the session, you can prepare for it and it's going to be so much amazing, right? Okay, so one last thing before we actually start with our session, right? Okay, it's regarding the JEE and NEET Crash Course. So why we say that you have to join this JEE and NEET Crash Course? It's simply because, okay, you will get a personal mentoring. A personal mentoring means we'll help you a lot, so that in this coming days, okay, within the limited days, how can we make a proper timetable so that we can cover the entire topics for the upcoming JEE. And along with that, we are going to discuss the entire topic, okay, along with the theory. That's the important point of the crash course, which means within this limited time, we are going to cover all the theoretical, okay, all the theory of all the chapters, and it's going to be so much amazing, isn't it? And along with that, we are going to make you so much of questions. You're going to do so much of questions, okay, in the form of assignments. And don't you want to analyze how much you have learned after all these things, right? So that's why we have the mock test also planned in this crash course. So you are going to do so much amazing in this. I do know that. So you can come and join here. What do you have to do? The link is given in the description below. So click on the link. Actually, this costs 10,000 rupees. But just because you are attending my class, I'm giving you a 20% discount, which means you are going to get this course just for 8,000 rupees by applying the code of AMECC. Write it down now itself. You don't want to miss this coupon code AMECC. So I hope every one of you are super ready for the very first question to be discussed, right? What do you all say, Siddhant? Okay, and everyone in the classroom? So yes, here we go with the very first question. What is it? Let's see. 400 millihenry coil. Okay, millihenry coil means what kind of a coil? Inductor coil, right? Of negligible resistance is connected to an AC circuit in which an effective circuit current of 6 milliampere is flowing through it, right? Okay. Find out the RMS voltage across a coil if the frequency is 1000 hertz, right? So if you want, we can actually draw the figure. Here we have an inductor coil of L value of 400 into 10 power minus 300 because it is millihenry is given, right? Okay. So through this, an RMS current, because whenever a current is being defined, right, it will be the RMS value of a current. So it is 6 milliampere if you are providing an alternating voltage to this particular circuit, right? The question is, what is the value for RMS voltage? What is the formula? That's equal to IRMS into the resistor in the circuit, right? So what is the resistance, you call it, which is provided by an inductor in the circuit? We call it as, yes, inductive reactance or XL. And what was the formula for that? What was the formula for inductive reactance, right? You call it as L into omega. Okay, so VRMS is equal to IRMS into L omega. IRMS, isn't it given? And you see, yes, you can see that it's 6 milliampere. That is 6 into 10 power minus 3. L value, tell me the value of L, which is the inductance value. It's very simple. Yes, we have it as 400 millihenry or 400 into 10 power minus 3 into omega. How can you write omega in terms of frequency? How are we going to write? Omega is equal to 2 pi f, right? So omega is equal to 2 into 3.14 into frequency is equal to 1000 or 10 power 3. So we can make the simplification, right? So 1000 is being cancelled with 10 power 3. Yes, it's gone. So what is remaining? So 10 power 3 into this 2 zeros. So it will give us 10 power minus 1. Then 6 fours are 24 is remaining. Okay, rest of the things are 6, 3 twos are 6.28, right? So we are going to get the answer as 24 into 6, almost 120. So yes, 150. So with 10 power minus 1, it is 15.072 is going to be the value for what? VRMS. Is it clear? So just like whatever you do in a resistor circuit, which means a circuit with a resistor, here we are having an inductor. So the resistance provided by the inductor is called as what? Inductive reactance with the formula or L omega, right? Yes, Robert, we are going to do it. I promise you, you don't have to worry about it at all. Now, here we are with the sprint series for JEE, right? So, I think you are going to actively participate here in the classroom because we are going to discuss a lot many questions. Along with that, whatever theory is required for doing that, that is also being discussed here, right? What do you all say? Yes, we are going to do, Vijay. Don't worry at all. But be here for the right for the time being and enjoy all the questions and understand all the concept, okay? Because once we start doing the theoretical class, it's going to be so much easier once you be here in the class and listen everything whatever it is going to be discussed there. Fine. So you're going to be here, right, with so much of enthusiasm, with so much of energy, and with so much of excitement. So I'm counting every one of you, and here we are with the next question. Here we go. In the adjoining circuit, okay, so you have the circuit, the figure of the circuit here. Calculate the inductive reactance and the capacitive reactance, right? What should be the source frequency so that the two reactants become equal in magnitude? question, what would be the impedance of the circuit, right? So let's start with the first part here. The question goes like, calculate the inductive reactance and the capacitive reactance. What are these reactances? It is the resistance provided by the respective elements, which means the inductor's resistor is called as inductive reactance, and the resistance provided by the capacitor in an AC circuit is called as capacitive reactance, right? We should be finding that out first. So how can we find that out? It's very simple, because XL, which is inductive reactance, is given by L omega, right? Okay. So what is the value for L? L is equal to how much? It is 50 millihenry, 50 into 10 power minus 3. Okay, then you can start searching for omega. Okay, it's not directly given, but you all know that whatever is a coefficient of time, that's going to be omega, right? Because sine omega t, that's how we usually write. So omega value is 1000 or 10 power 3. So you have XL is equal to 50. Now XC, that is 1 by C omega, that is 1 by, what is the value for capacitance? That is 0.2 into 10 power minus 6, right? Into omega is equal to 1000. So this will be converted as 10 power minus 3. It goes up as 10 power 3 divided by 0.2, right? Okay, now this will be 10 power 4 divided by 2. That is going to be 10 power 4 divided by 2. Yes or no? Yes. And what do we have then? We have 10 power 4, that is equal to 10,000 by 2. We're going to get it as almost 5,000, right? Fine. Sure. We are going to do it so soon, Vijay. Don't worry at all. Okay, it's a promise. Now, I hope till this part it's clear to every one of you. No doubts and no issues, I suppose. Right? Okay. Now we are gonna continue it. Right? So I think we can use the space here. Okay, let me use the eraser, get it cleared so that the space will be available for the next topics. No doubts, very good. So that's amazing. So Vijay and Robert, so everyone is actively here in the classroom. I'm so happy for that. Right? Okay. Now let us continue with the second part. What should be the source frequency? Okay, what frequency we have to provide so that the two reactants becomes equal in magnitude? Okay, two reactants means XL, which means the capacitive reactance and the inductive reaction. XL is the inductive reactance, XC is the capacitive reactance, right? For both of them to be equal, what should be the value for frequency given in the source? That's a question. So if these both has to be equal, just expand the equation. XL, which is the inductive reactance, is given as L omega. XC is equal to 1 by C omega. So omega square is equal to 1 by LC, right? Or omega is equal to 1 by root of LC. Start substituting. Omega is equal to 1 by root of, what's the value for L here? What is the value for L? L is equal to, yes, 50 millihenry. So 50 into 10 power minus 3. Yes, that's done, right? And C value is equal to 0.2 into micro. It's 10 power 6, all under the root. Fine. Okay, now moving on again. 1 divided by root of, okay, 50 into zero point 0.2, that's equal to 5 2s are 10, right? 10 into 10 power minus 3 into 10 power minus 6, it is 10 power minus 9. 10 into 10 power minus 9, it's 10 power minus 8. 1 by root 10 power minus 8, if I write it here, that is 1 by 10 power minus 4, it goes up as 10 power 4. So the value for angular frequency should be 10 power 4, right? And omega is equal to, you all know it is 2 pi f, that is 10 power 4, or f is equal to how much? 10 power 4 divided by 2 pi. Okay, so very simple. I hope it is clear till this part. But the options are given for the very last part of the question, which is what would be the impedance of the circuit, right? Impedance means the total resistance of this LCR circuit is a question, right? So how it can be done? Okay, what happened to the smart board? Smart board, because the studio was not available. Whichever studio was available, there is some issues there. So I'm taking my classes in my laptop. Is it fine? I hope everything is clear to you, right? Okay, so yes, we are moving on. Dharnika, hi, good to see you back again. No problem. Yes, very fine. Now, the impedance formula, I hope you all remember. What is the formula for impedance, which is the total resistance in the circuit? That's equal to root of r square plus xl minus xc the whole square. I hope you all do remember this, right? So it is already given that the two reactances xl and xc are equal. So xl minus xc is going to be 0. So z is equal to root of r square, that is r. So the total impedance once the two reactances, once the inductive reactance and the capacitive reactance are equal is going to be how much, right? The resistance that is present in the circuit, the value for resistor in the circuit, that is equal to how much? 100. So the total impedance is going to be 100 ohm. Yes, is it fine? And the channel is asking every one of you to hit the like button, so don't forget that. And I hope you are already loving all the questions whatever we are discussing. Okay, so I know that nowadays schools has reopened, so I hope everything is going good, right? To meet your friends after a long time and everything. So I'm totally loving the love that you're having for physics. Okay, just after the school you started opening the YouTube and yet you're here. It's good. I'm all good, Skadoosh, and that's a unique name, and it's a good to hear that. Anyway, yes, let's move on. That goes without saying, right, Vijay? Yes, I can understand your feelings. So moving on. So this is a very huge problem. So you have to listen to me for each and every step, then only you'll be understanding. So I hope everyone is with me. So here we go with a question. An arc lamp requires a direct current of 10 ampere at 80 volt, right? Which means here a lamp is considered to be the one which is having a resistor and an inductor in the circuit, where we are providing initially, okay, initially what we are providing? Initially we are providing a direct current to it, right? Okay, so initially we are providing a direct current to it. So how much is provided? 80 volt is provided, and the current that is equal to 10 ampere. We know that whenever a direct current is being provided across a resistor and a combination of an inductor, right? No voltage is getting dropped across the inductor, because you have to know that the resistance of the inductor, which we call it as the inductive reactance XL, is L omega. Here omega, which is frequency, is 0 because we are providing a direct current. It is equal to 0. So the inductive reactance is equal to 0 for the given inductor here. So whatever current flows, okay, it is only dropping the voltage across the resistor. So we can say that V is equal to I into R in this particular case. And the value for resistance is V by I, which is equal to how much? V is 80 divided by how much current is equal to 10, that's equal to 8 ohm. So let me write it here. We got the value for resistance as 8 ohm. Now we are removing this particular battery, okay, which is actually providing a direct current, and instead we are providing an AC current here with an RMS voltage of 220 and a frequency of 50 hertz. The question is the series inductor needed for it to work is. So for this given arc lamp to work, you know that it has to be provided a power. Okay, what is the power formula? We can use any of the formulas that we all know. Let me use the formula as I square R, right? So initially when you were providing a direct current, the power is calculated as I square into R, because I have already told you when the direct current is being applied, inductor doesn't has any effect to the circuit, right? Okay, so power is equal to I square into R, and what is the value for I here? 10 ampere into the resistance value. Now fine, once we are providing an AC, you have to know that the power that is getting dropped across the inductor is equal to 0 when you are providing an AC also, which means the average value of power that is dropped across an inductor, it is 0. So even if you are providing an AC in an LCR circuit, the power is only getting dropped across a resistor. So still the equation for the power is going to be I square R. So if the circuit wants to be working, even if you are providing an AC, right, to the circuit, the same amount of power should be delivered. So the initial and the final power should be the same. For that, the current value should be the same because the resistance is already a constant, right? So the current in the first case and the second case should be the same here. Now, in an LR circuit, how will you calculate the current? That's the next part. What is the equation to calculate the current? It's very simple, right? That is equal to V divided by net resistance, that we call it as impedance, V by Z, right? Okay, very good. Now, the value of I that has to be there in the circuit is 10 ampere. We already know the voltage that is equal to 220, right, divided by what is the value for Z. Z, which is impedance, is root of R square plus XL square. I hope you all remember, right? In an inductor resistance circuit, what is the equation to find out the impedance, right? Yes, then it is done. So this is equal to 10 is equal to 220 the whole divided by root of R means, sorry, what was the resistance? The resistance value was 8 square plus XL is equal to L omega, right? Let me write it here. XL is equal to L omega. So what is the value of L? That has to be found out. L into omega is equal to 2 into pi into what is the frequency? That's 50 hertz. It's given. So what is the only unknown in the equation? What is the only unknown? Yes, Shamsul. Shamsul is so much active in the classroom. I'm so happy. So the only unknown is inductor. Can't we directly find that out? So you can actually make the cancellation here 0 0. So this is squaring it, 8 square plus 2 pi 50 into L is equal to 22, right? Here from here, if you find the value of L, you are going to get the value of L as 0.065 Henry. Got it? Okay, planted aquarium hobby. Wow. So what's your real name? Anyway, I hope you all got this particular answer to this question. Have you all enjoyed till this part? And still ready and excited for one more question, everyone? Are you all ready for that? Yes, clear, Shamsul. Very good. Sujit, very good. Hi, Sujit. Yes. Okay. Then let's move on to the next question. That's a very beautiful question. Listen. An alternating voltage is given. Vt is equal to 220. 220 is what? The maximum value of voltage. Sine of, this is what is called as the phase of the angle, right? Okay. So this is the phase of the given voltage is applied to a purely resistive load of 50 ohm. So it is a completely resistor circuit. You know that there is no phase difference between the voltage and the current in a purely resistive circuit, right? Okay. So the value for the phase for the current and the voltage, it's going to be the same. So if V is equal to V naught sine omega t, the value of current I at any point of time will be equal to I naught sine into omega t. So here the phase is the same. So it is 100 pi t, needless to say. Okay, phase difference is 0, phase remains the same. That's how you tell it, right, Shamsul? Okay, so there is no difference in phase. So whatever is the phase of the voltage, phase means the angle which can represent the current position of the voltage, right? Yes, and here it is same 100 pi t for the current also. The question is, let us draw the phasor the diagram. So the current moves according to the sine curve like this. Okay, this is what it tells you. The equation tells you this. The question is the time taken for the current to rise from half of the peak value. So you know that this is the maximum value for the current, which is I naught. So let's say that this is the point, okay, which is this is the point which is half the maximum value. the time taken for the current to move from this point to this point, how much time is taken? That has to be found out, right? Okay. So how can you find that out? So it's very simple. First, let me remove this part so that I can draw a bigger picture and you will be understanding in a better fashion, right? So here we have a bigger picture. So this is the maximum value point, let's say, and let's say this is equal to some T2 value, and let's say this is half the maximum value for the current, and time at that is equal to T1. The question is, for the current to rise from this point to this point, how much is it? Till here it is T2, till here it is T1. So how will you find out? T2 minus T1 is the time taken for the current to rise from half the maximum value to the maximum value. I hope it's clear. So now our duty is to find the value of T1 and T2, right? Okay, how can we find out? Because when the time is T1, the value for the current is equal to I naught by 2. So the value for the current is equal to how much? I naught by 2, okay, I naught sine 100 pi when time is T1. I hope you got it, right? I'm just applying the value in the above equation, that's all. So what will you get? I naught cancels. It's 1 by 2. Sine of an angle is 1 by 2. So what does the angle corresponds to? 100 pi T1 corresponds to sine 30, because sine of 30 is equal to 1 by 2. 30 means pi by 6, right? So pi cancel. We'll get the value of T1 as 1 by 600. Simple. Now I hope everyone might got an idea to find the value of T2, because when the wave reaches at the time T2, the value for the current I is equal to I naught. So putting I equal to I naught is equal to I naught sine 100 by T2, right? I naught cancels. Sine of 100 by T2 is 1. So the value for the angle corresponds to 90 degree, or 100 pi T2 corresponds to pi. Yes or no? Any doubt till here? No. Now only what is left is a basic calculations, right? Pi cancels, right? The value for T2 is equal to 1 by 100. Is it clear till this part? Okay, so a small thing we have missed, right? Pi means 180, it's pi by 2, right? Pi by 2 means 90 degree, because the sine of 90 is equal to 1. So 100 pi T2 is pi by 2, so this becomes 200. A small here and there changes. Now, what was the question? The time required for the current to move from here to here, that is equal to T2 minus T1, as I have already told you. So what is T2 minus T1? 1 by 200 minus 1 by 600. That is 1 by 300, and 1 by 300 corresponds to how much? 3.3 milliseconds. Clear everyone? I hope you all enjoyed every question what we have discussed in the session, understood all the concept, and everyone is having a smile on their face thinking that yes, we learned these many concepts and did these many questions from the chapter of AC, right? I hope the chapter is more clear to you after doing these many questions. Ameer, clear? Okay, I'm so much happy to know that. So what do you have to do now? If you have liked, okay, as you already told me, yes, you love the classroom, move your cursor and just click on the like button. That's all. And the second job you have to do is, if you love this class and if you feel that your friends are also gonna get benefited from the same classroom, please share it with your friends and ask them to come and join the classroom. And one last thing, if you don't want to miss any of the classes, I know that you don't want to miss any of the classes, right? Okay, so now itself click on the subscribe button, because you will get the notification whenever a new video is being live or once it is being uploaded. Okay, so thank you so much for being here. It was so much amazing. Okay, till we meet next time, bye everyone and take care.